This is a tutorial for the Compaction Test Lab of the Geotechnical Engineering course Civ E 3208. The purpose of this lab is to determine the water content which results in a maximum dry density. Density is one of the controlling factors of soil, as it governs attributes like shear strength, compressibility, settlement, and hydraulic conductivity. A more dense soil will have a higher shear strength, less settlement, less compressibility, and less hydraulic conductivity. To find the optimal conditions for a given soil application, we will need to find the maximum dry density of the soil as well as the moisture content at that density. A given soil sample with a given amount of compaction energy will have a density to water content curve that looks like this. At lower water contents, the grains of soil are locked together and therefore compaction energy has less effect. Once water is added, soil grains are more freely able to move past each other and thus rearrange themselves in a more dense state, achieving a peak density. If additional water is added, then the soil will become saturated. Since the water is relatively incompressible, the overall soil density is reduced. To find these, we will need to conduct compaction tests, also called standard and modified Proctor tests. To perform either of the compaction tests in this lab, we will need about 6 pounds or 3 kilograms of dry soil passing sieve number 4. Place an empty container on the scale, zero the scale, and measure this amount. Record the mass of the sample as the dry mass. Before you add water to the sample, empty the sample into a metal tray like this. Now you will need to add water to the sample for a moisture content of about 5%. Calculate the amount of water needed by multiplying the dry mass by 0.05. Measure out the amount of water needed in a graduated cylinder, and mix it with the sample like this. This sample is now ready for the test. This is the Proctor mold in which we will be performing the compaction tests. Before you begin the test, measure the mass of this mold and its base. The apparatus consists of the following parts: the base with 2 vertical screws, the test mold, which can be removed, and the top cap, which aids in filling the mold and can also be removed. You will also need to label and record the mass of about 6 empty moisture containers, such as these. Now we can fill the mold with our sample. For the standard Proctor test, the objective is to compact 3 layers of soil within the space of the test mold. Fill the mold like this. For the first layer, fill the mold about half of the way up. To ensure a standard amount of applied compaction energy, we will be using the 5.5 pound hammer to compact the soil. Place the hammer in the mold like this. Lift the handle to its maximum height of 12 inches and drop it. 25 drops are needed to compact this layer of soil. As you're doing this, work your way around the outside of the mold so that the soil layer is compacted evenly. For the second layer, fill the remainder of the mold with soil. This will compact to roughly 2/3 of the mold. Again, use the 5.5 pound hammer 25 times from its maximum height of 12 inches to compact this layer. For the final layer of soil, attach the top cap to the mold like this. Now fill the extended mold with soil and compact the soil the same way as before. Once this is done, remove the top cap. Now take off the excess soil by using a flat tool like this. Clean the base of any loose soil that may have come off. Next, measure the mass of the mold and compacted soil. Record this mass in a table like this one. Now fill one of your moisture containers with a sample of soil from the mold. To do this, simply use the container itself to scoop some of the sample from the mold like this. Record the mass of the container with some of the sample in it, and place the soil in an oven to dry. You will need to repeat the compaction test at greater moisture contents until you find the maximum density. First, empty the mold from the previous test and reset the mold. Mix the soil a bit. For the next test, increase the moisture content of the sample by roughly 2 to 3%. For a sample mass of 6 pounds, this means adding about 70 milliliters of water. This does not need to be exact. Mix the soil again so that it's uniform. Now we are ready to perform the test again at a new moisture content. As before, fill the mold in 3 layers and compact each layer with 25 drops or blows from the 5.5 pound standard Proctor hammer dropped from a height of 12 inches. Measure the mass of the mold and compacted soil and record it in the table. Notice that since we've added water, the grains are more consolidated and therefore the mass of the mold and sample is higher than before. You will need to repeat the test until you find the maximum density, each time increasing the moisture content by 2 to 3%. Since the mass and volume of the mold remain constant, you will know that you've found it when the total mass of the compacted sample plus the mold begins to drop. In our case, we found the maximum density at test number 4. However, we needed test number 5 to confirm that the total mass beyond this was dropping. Now that we have completed the standard Proctor compaction, we will need to calculate the soil density and moisture content for each of our tests. After 24 hours in the oven have passed, record the mass of each of your moisture containers plus the now dry soil. Calculate density and moisture content for each test. Now plot the density of the compacted sample against its moisture content. To do this, use a graph like this, with density in grams per cubic centimeter on the y-axis and moisture content as a percentage along the x-axis. Plot all of your data points from each of your tests like this. Connect the points with a curve. The peak of the curve is the optimal moisture content. Since the degree of compaction depends largely on the amount of compaction energy applied, we will be conducting the Modified Proctor test, which applies more compaction energy. For this test, you will need a new soil sample. Once again, fill an empty container with about 6 pounds or 3 kilograms of soil. The Modified Proctor test is performed very similarly to the standard Proctor test. These are the differences. Instead of using a 5.5 pound hammer at a height of 12 inches, we will now be using this 10 pound hammer at a height of 18 inches. Instead of 3 compacted layers, our mold will now be filled with 5 layers. For the first layer, fill the mold about 1/3 with soil and then compact it. For the second layer, fill the mold about 2/3 of the way. For the third layer, fill the mold completely. For the fourth layer, attach the top cap and fill it to about 1/3. For the fifth and final layer, fill the top cap to about 2/3. Just like with the standard Proctor test, take off the cap, clear the excess soil, and record the mass of the mold plus compacted soil. Take a moisture container, label it, record its mass, scoop a sample of soil from the mold, record the mass of the sample, and place the sample in an oven to dry. And finally, empty the mold for the next test. It will be more difficult to empty the mold this time, as we have applied much more compaction energy. You can use the flattening tool or the hammer to help you do this. Again, just as in the standard test, we will need to repeat this test at increasing moisture contents until we find a maximum density. We will know this once the total mass of the soil plus mold begins to drop. Density and water content are calculated in the same way as before. Once again, plot the points on the graph, connect them with a curve, and find the moisture content corresponding to the maximum density. This concludes the compaction test lab.